All right, my friends, let's take a look here. All right, so for the first problem, given the recursive definition, write the first 5 terms and write the nth term of the sequence as a function of n. Do know it said that you know, if at all possible, you need to justify and show some work. So let's show some work here. Using the recursive function, you could just kind of ask it what happens when k is 1. So kind of replacing everything with 1 and then simplifying. So it would say a sub 2 is negative 2 plus a sub 1, and a sub 1 was 10, so you could just replace a sub 1 with 10. And that would be a quick way to show a little work. A sub 3, if you plug in a 2 here and here, it would say a sub 3 is negative 2 plus a sub 2, which we got 8 already for that, so we'd get 6. And then sooner or later, you could see, you know, if you started grouping the terms, you know, the first term was 10, the second we got 8, and the next one we got 6. And then sooner or later, you could notice that they're just subtracting 2 every time, and so the next one would be 4, the next one would be 2, etc. Hopefully that makes sense. For part B, it says write the nth term of the sequence as a function of n. So we recognize this as an arithmetic, and the common difference is negative 2. So one way to write the rule would be to say the nth term would be your first term plus n minus 1 negative 2's. If you wrote it like that, then the parentheses are necessary. You could have written it also like this, or you could have simplified it just by combining like terms. You'd end up with negative 2n plus 12. Okay, so I'm just going to box each of these because they all could have been, they're all considered equally correct for that. Okay. All right. Let's see. How should we do this for points? Let's make each of these, your first 5 terms, be worth half a point each. So 2.5 points total for the first 5 terms. Let's make the next half point be for notation. So that could be basically the braces if you used this list notation. Or instead if you listed it as a sub 1 is 10, a sub 2 is 8, a sub 3 is 6, a sub 4 is 4, and a sub 5 is 2. That could count as the same notation. So we'll just say correct notation is worth half a point. Okay. And then that gives us 2 points for this part. So we'll just give you 2 points for getting one of these 3 versions of the answer and call it good. Okay. For problem 2 here, say just a more complex recursive definition. With this, it may have been all the more important to have kind of said what happens when k is 1, for example. So when k is 1, you would have gotten a sub 3 is 5 times a sub 2 minus 2 times a sub 1. And they gave you the second term as 1 and the first term as 1/2. All right, and then simplifying this, it looks like I get 4. A sub 4, you could have gotten just by going up to the function rule and asking it, what would you say when k is a 2? And so you'd get 5 times a sub 3 minus 2 times a sub 2, which would be 5 times a sub 3 we just got. It's 4 minus 2, and a sub 2 is given to you as 1. So it looks like we've got 18 there. And then you just need to do one more round of this to get the 5th term. So that would be 5 times a sub 4 minus 2 times a sub 3, which simply would have been found by setting k equal to 3 here and simplifying as you go. We'd end up with 5 times a sub 4 is 18 minus 2 times, and a sub 3 was 4, which would be 90 minus 8, it looks like, so it would have been 82. So your final answer, written in set notation, would have been, a sub 1 was given as 1/2, a sub 2 was 1, a sub 3, 4, a sub 4, 18, a sub 5, 82, and it would have continued in that manner. Okay, so this is a 5-point problem, and we'll give you 5 points, 1 point per term. So hopefully you got at least the first 2 points, since those were given to you. And then that's it. Okay. All right, I would say problem 3 was, for some people, kind of threw some folks off. So I do want to show 2 methods for problem 3. The first method, not very many people did, but I think some folks may have wished they had. And then the second method was a little bit more textbook. So, and that's something that as we get into harder mathematics, you do want to consider. For most problems, like, is there more than one way to do this? And so one way to have done problem 3 would be to use if in doubt, expand it out. So if we started expanding the terms, then the first term would have been 6. The second term would have been negative 0.6, and then we would have added 0.06, subtracted 0.006, added 0.0006, you know, and so on. 1, 2, 3, 4, 5, 6. One more. 1, 2, 3, 4, 5, 6. Okay. Okay, so these would be the terms. Now let's talk about, and this is something in your homework that you had to do a couple times, but I don't know if you realize like the value of it. It's called a sequence of partial sums. So the first partial sum in this case would be 6. And then the second partial sum would be just 6 minus 0.6. So that would be 5.4. And then if you were to then hug in the next term, you'd get 5.46. And then if you hug in the next term, you'd get 5.454. Hugging in the next term, so adding this next term in, you'd get 5.4546. Okay, then subtracting off the next term from my subtotal, I'd get 5.4546. Wait, 5. That would have been a 6, but I'm subtracting that, so 4. And then adding this one on. We would have gotten that, okay? So this is called using a sequence of partial sums. And you can see a pattern. And this is not the only way to have done it, but this is one version of the correct answer, and this would be full credit if you did it this way, okay? And I feel like if we did it this way, if I was to, like, you know, change the 7 to a 9, I feel like most people at this point would guess what that would have been, just by the pattern that's kind of showed up here. So there's one method. Another method where you get something equivalent, but it looks a lot different, would be where you use the sum formula for, this would be a 7th partial sum of a geometric series. So that would look like this. So the first term, which is 6, times 1 minus your common ratio, which is negative 1/10, to the nth power, which in this case would be 7, divided by 1 minus the common ratio, like so. And then from there, it would just be a matter of following the order of operations. And before I go too much farther, let's talk about kind of credit as you go. This little step right here where you correctly used the formula, use the right formula and use the right formula correctly, this will be worth 3 of the 5 points. So even if you messed up after this, you should have at least locked in 3 of the points. Now let's just follow the order of operations. So 6 times 1, and then negative 1/10 to the 7th would be negative. So you'd have minus, negative, and then you'd have 1 over, and then a 1 with 1, 2, 3, 4, 5, 6, 7 zeros after it. Like so. And then on the bottom, you're basically just adding 1/10. Okay, and then let's just clean things up a little bit. You're subtracting a negative, so you're basically adding. And then on the bottom, you have 11/10. Adding 1 and this little fraction here, you'd end up with 1, 2, 3, 4, 5, 6 zeros and a 1 over a 1 with 7 zeros. And then dividing by 11/10 is like multiplying by 10/11. Okay, now let's cancel the 10 with this right here. And then let's make sure that when you multiply 6, you treat it like 6 over 1. You don't accidentally treat it like 6 over 6. So let's multiply these two together. You get 6, 1, 2, 3, 4, 5, 6 zeros and a 6. And then on the bottom, instead of a 1, you'd have an 11. There we go. And the last thing you need to do is reduce your fraction. These are both even numbers, so you could divide both by 2. So you'd have a 3, 4, 5, 6, and a 3. And on the bottom, instead of 110, you'd have 55. So you'd have 55. And then 1, 2, 3, 4 zeros after it. No, wait, 5 zeros after it. There we go. And this would be your reduced answer. Oh, there you go. Okay, so along the way, let's see, what did I have for partial credit on that one? Okay, let's say passing through, where did we get to? Yeah, passing through this at any time would be worth the 4th point, and the 5th point would be for getting the reduced answer right there.